All right, in today's video, we're going to be doing 14.7, which is the conclusion of chapter 14, and we're going to be looking at more application problems from 14.6. But this section is devoted all to applications and not just solving. All right, so we're going to start off with questions like this, where it says the denominator of a fraction. All right, so we have a fraction. Denominator is the bottom. Is 3 more than the numerator, right? If I don't know what the numerator is, I'm going to call it x. And if it says 3 more than, then that would mean whatever that value is, I can add 3 to that, and it would be 3 more than the numerator. If both the numerator and denominator increase by 4, the new fraction. Okay, gotcha. So if both numerator and denominator increase by 4, so that means now I'm going to add 4 both to the top and the bottom, so the numerator and the denominator. The new fraction is equal to 3/4. Find the original fraction. So what we're going to figure out is what was this fraction? So I'm going to simplify this up a little bit and say this is x plus 4 over x plus 7, which makes sense because, again, this was 3 more than the denominator equals 3/4. Now I'm back to section 14.6 and I'll cross multiply. So I get 4 times x plus 4 equals 3 times x plus 7. So I'll distribute the 4. So 4 times x is 4x. 4 times 4 is 16. 3 times x is 3x. And 3 times 7 is 21. Now I'm going to subtract 3x because I'm trying to get x to one side. I'm going to go ahead and subtract 16 because I want everything away from the x that I'm moving. So 4x minus 3x is just x. This goes away. And 21 minus 16 would be 5. All right, so here is the issue with this. The question is not what x equals. We determined that x equals 5. The question is, what's the original fraction? So when you have that, you have to go back to your beginning and now plug in that x. So this becomes 5 plus 4, and then this is 5 plus 3 plus 4. So that becomes 9, and then that would be 8. 8 plus 4 is 12. And so the original fraction was 9/12. Oh, I lied. Hold on. Let me backtrack there a little bit. I forgot there was another part to that. So the very beginning of it says the denominator of a fraction is 3 more than the numerator, and then if you add 4 back. So I actually need to take that 4 away. And this was actually my original fraction. And then it told us to add 4 to both sides, and I would get 3/4. So this is the one that I actually want to add or replace the x with 5 with. So I actually get 5/8 as the answer that it's looking for. Right. So on some of these questions, you might be able to do all the math correctly, but then not actually answer what the question is asking. So definitely pay attention to the question on the first part of the homework. All right, let's look at number 2. Number 2 says an electrician can wire a house in 12 hours. Her assistant takes 18 hours to wire the same house. How long would it take them to wire the house together? All right, so the way we're going to do this is we're going to make a proportion. This proportion has to be like this. So you can do the person over hours, amount of time it takes them to do the task. So in this case, an electrician can wire a house in 12 hours. So one person can do it in 12. This is the electrician. Another her assistant can do the wire a house in 18 hours. So one person can do it in 18 hours. But the question is how long would it take for them to do the house together? In this case, I want to do. So how long can I do one job together? So this is really, I would say, let's not say person because that's going to be misleading. It's going to say job. So an electrician, oh, so an electrician can do one job in 12 hours. The assistant can do one job in 18 hours. So together, they can do the job in how many hours? So we need to add these up to determine what the result is going to be. So the way we do this is we're going to multiply by the least common denominator. All right, so the way we do that is we determine our least common denominator. We did this beginning of chapter 14. So 12 breaks down into 3 times 4, and then 4 breaks down into 3 times 2 times 2. 18 breaks down into 2 times 9, and then that would be 2 times 3 times 3, and then x is just x. So we see that they share 1 3 together and 1 2 together. So our least common denominator will be 3 times 2, and then I got a leftover 2, leftover 3, and a leftover x, right? This was one of the ways, or we could have multiplied and done a chart to figure out what multiplies to 12 and 18, or what 12 and 18 can both be in common by. Whichever one y'all decide is the easiest. So 3 times 2 is 6, 6 times 2 is 12, 12 times 3 is 36x. So again, the other way, if you don't remember, and I'm good with either one. So this is what 1 times each one of those are. 2 times is 24, and then that would be 36. And then this would be 3 times 12, which is 36. And then I can say, oh, look, 36 is the denominator. I'm good either way, either this process or this process. Sometimes this is easier, sometimes this is easier, but it doesn't matter to me. But 36x is the least common denominator. So that means I'm going to multiply this entire equation by 36x. And when I do that, I get 1 times 36x, which is 36x over 12, plus 36x over 18 equals 36x over x. 36 divided by 12 is 3, plus 36 divided by 18 is 2. Oh, I forgot the x. And then 36x divided by x, the x would cancel, so I'm left with 36. So 3x plus 2x is 5x equals 36. Now I'm going to divide both sides by 5. And that looks like that would be 5 goes into 36 7 times with a remainder of 1. So in this case, I actually don't know how they want you to keep the, I naturally just went to this because it's a word problem, but might want it in mix. I wrote a note for it. Oh, it takes either or. So you could keep it as this, so or you could keep it as turn it into 7 1/5. Either one, the homework accepted. All right, but technically, I guess we need to add hours. So if they work together, they can get the job done in 7, technically 7.2 hours. All right. All right, let's look at other word problems you might see. Let's look at number 3. Number 3 says a mother can carve a pumpkin. All right, so task over hours. The task here is carving a pumpkin. So it says a mother. Here's a mother. Can carve a pumpkin twice as fast as her 8-year-old son. All right, so I do not know how fast the mother can go, so I'm going to call it X. But I do know son, his task would take 3 times longer since the mother can do it 3 times faster than her. So for instance, let's say mom can wash the car in 2 hours. Then to figure out the son, it would be 3 times 2, which is 6. So the son would take 6 hours because the mother can do it 3 times faster. So together they can carve the pumpkin in 3 hours. Oh, we're doing pumpkins. I don't know why we thought cars. or why I thought cars. So together they can complete this one task in 3 hours. How long would it take each of them working alone? All right, so here's our equation. And so now I'm just going to figure out the least common denominator once again. So I have x, 3x, and a 3. This is just an x. This is 3 times x, and this is 3. So I share an x, and I share a 3. So my least common denominator here is 3 times x. So 3x times 1 is 3x plus 3x over 3x equals 3x over 3. X's cancel, got 3, cancel, I have them left with 1, and then 3's cancel, so I'm left with x. So 3 plus 1 is 4. So that means that mom can carve this pumpkin in 4 hours. So mother, because it wants to know what each, can do this task in 4 hours. But then son, 8-year-old son, it would take him 12 hours to carve a pumpkin. All right, so always go back to what the question is asking. All right, let's look at another one. Let's look at number 4. 4 says Jeanette's pool normally takes 4 hours to fill. Last time it took, so we got task over hours. Jeanette's pool, it takes 4 hours to fill. Last time, oh, my bad. Normally takes 4 hours to fill. Last time it took 10 hours to fill, and she found that she had left the drain open. So how long would it take to drain the pool once it is completely filled and only the drain value is open? Interesting. Okay, so Jeanette's pool normally takes 4 hours to fill. Last time it took 10 hours. So last time the total task took 10 hours to fill, and she found that she had left the drain open. So here's her feeling. Here's the drain being open. And we don't know how long it takes for her to drain the pool, but we do know that draining would take away from Jeanette feeling. How long would it take to drain the pool once it is completely filled and only the drain valve is open? So it takes 4 hours to fill it. Last time it took her 10 hours to fill it because the drain was open. So now we have to determine, that's why we're subtracting instead of adding, how long it would do in this situation. How long would it take her to drain the pool with just this kind of operation? All right, so now that we have our equation, now we got to determine our least common denominator. So we have 4x and 10. 4 breaks down into 2 and 2. X is just x, and 10 is 2 and 5. So I share a 2, and that looks about it. So that means my least common denominator would be 2 times x times 5. Because there's the 1, 2 they share in common, plus the other 2, plus an x, plus a 5. So 2 times 2 is 4. 4 times 5 is 20x. And now I'm going to multiply both of the entire equation by 20x. So this becomes 20x over 4 minus 20x over x equals 20x over 10. So 20 divided by 4 is 5x. X is canceled, so I'm left with minus 10. 20 divided by 10 is 2x. Again, I'm going to try to solve for x. So I'm going to subtract 2x. I'm going to go ahead and add my 20 over because I want that constant to go away as well. So 5x minus 2x is 3x equals 20. Divide that by 3, and x equals 20 over 3, or what's that? 6 2/3 hours. Do not know why that started going sideways. All right. So with the information that was given to us, she can either fill her pool up in 4 hours or she can drain it in almost 7 hours. All right, which makes sense because if I'm filling and draining at the same time and I'm able to actually fill it up, I can put more in, I can fill the pool up faster than I can drain it. which if you have a pool or have ever had a pool, that's definitely the truth. So let's look at another type of problem. Let's look at number 5. So on Lake Westbance, a man can paddle his kayak at a rate. Oh, these are rate problems. So the one thing that I think this comes from chapter 9 or chapter 10, I forget now. But when you're dealing with distance, rate, and time, they expect you to know that the equation is D equals RT. Distance is equal to your rate times time. So if you're traveling 60 miles an hour in 2 hours, you would gone to 120 miles. That's how I usually try to remember it. So again, so on number 5, it says on Lake Westbance, a man can paddle his kayak at a rate of 6 miles per hour. Right? So we can go, so a man can go 6 miles an hour on a lake. That's about as far as I know right now. So 6 miles per hour. So on a nearby Minnetonka River, it takes him the same time to paddle 6 miles downstream as it does to paddle 3 miles upstream. What is the speed of the river's current? Okay, so let's break it down like this. Okay, so we have our distance, we have our rate, and we have our time. If we were going downstream, the distance, same time to paddle 6 miles. So downstream, he's going 6 miles. And it says he can travel at the same so a man can paddle his kayak at a rate of 6 miles per hour on a nearby Minnetonka River. It takes him the same time to paddle 6 miles downstream. Okay, so we don't know the rate. That's what we don't know. I don't know the rate, but I do know it takes the same time. And time, if I divide by R, would be D over R. So this becomes D over R. So this would be 6 over R. And my upstream, he only travels 3 miles. And again, we don't know this rate. And then therefore our time would be 3 over the R. And the rate that we're calculating here is the speed of the river's current. All right, but it tells me it does the same time. So in this case, these things are equal to each other. So 6R is equal to 3R. So if I cross multiply, that's going to be 6R equals 3R. No, that wouldn't make sense. That'd be 3R equals 0. All right, let's approach this a different way. So if I have 6R over 3R, I'm trying to make these equal to the same. All right, common sense tells me the river must be 2 miles an hour, but mathematically this isn't working out. So here is what I can determine. I don't know the river's current, but I do know on his own he can go 6 miles an hour. So whatever the current is, I would add it to the speed of my guy. And if I still can travel 6 miles an hour, but the river current would be going against me, I would subtract it. So let's adjust it like this. So we'll say 6 plus r and 6 minus r. So when we write it out, we'll have 6 plus r equals 3 over 6 minus r. So what I'm doing now is if I determine the rate is my stream that I don't know, but I do know I'm traveling 6 miles an hour, if I'm going downstream with the current, I'm going 6 miles an hour plus what the current's going with me. So it's going to make me go faster. If I know I can travel 6 miles an hour on my own, but now I'm going upstream, I'm going against the current, so it's going to slow me down. So I'm going to use this adjustment to it to produce an equation. Now, earlier the equation I just had mathematically would have gave me 0, which isn't the answer. But then just looking at it, I can go, well, it's just double the time. So the rate of the current would be 2 miles an hour. But I need to make sure we approach this mathematically as well, because it's not always going to be that easy to see. So now that I'm at this, I can go, all right, well, this is going to be 6 times 6 minus r equals 3 times 6 plus r. I'll do 6 times 6, which is 36, 6 times r, which is negative 6r, 3 times 6, which is 18, and 3 times r, which is 3r. So I'll add 6r and subtract 18. So that'll give me 9r and 18. And then divide that by 9, and I can see my current of my river is 2 miles per hour, because that was the units. All right, so I could see that just kind of logically, but that's the approach you want to have. So with current, against current. All right, let's look at another one. Let's look at number 6. All right, so if a commercial airplane travels twice as fast as a private aircraft, and the private aircraft takes 2.5 hours longer than to travel 900 miles per hour, what is the speed? So again, we're dealing with distance, rates, and time. Time, again, remember, is distance divided by rate. So we have, let's see, so if a commercial airplane, so commercial airplane, and we also have a private aircraft. All right, so if a commercial airplane travels twice as fast as a private aircraft, so we'll say twice as fast as whatever the aircraft is. Whatever this private is, I don't know how fast that is, but the commercial can go twice as fast. And the private aircraft takes 2.5 hours longer, so that whatever its time is, this would be 2.5 hours longer to travel 900 miles an hour. So I'm at travel 900 miles. What is the speed of the airplane? Alrighty. And we know our time in this case would be 900 divided by 2r. And in this case, this would be 900 divided by regular r plus 2.5. So what I can see is that this would equal this, just like last time. So this would be 900 over 2r equals 900 over r plus, I'm going to convert this into a decimal, 2.5. And then my goal is to get rid of the fractions. So I have a 2r and an r. So when we do this part right here, I have a 2. This is technically a 1. And I have an r. I'm not going to repeat it. So therefore, I'm going to go like this. So this is 900 times 2r over 2r equals 900 over, or 900 times 2r over R plus 2.5 times 2R. That would cancel. So it gives me 900 equals, R would cancel. That'd be 1800. 2.5 times 2 is 5R. Issue is we're ending up with a negative number here. Hmm. All right, let's approach this a different way so we, again, mathematically get this correct. But if you kept that approach, you'd have got the right answer. It would have just been negative, and then you had to realize that you couldn't have negative, so you would make it positive. But we need to approach it as if it needs to be negative. All right, so here's what I'm seeing now. So if you have the commercial airplane, so travels 900 miles, twice the speed of the private aircraft. And we know that the two difference is this 2.5 here. That's what's really throwing me off. The 2.5 hours here. Let's just say, let's take this 900 over R, because this will take longer, minus the 900 over 2R, because I can get there faster. And I know the difference there would be this 2.5 hours. So let's approach it this way. Same process. We're going to multiply by 2R. So this gives me 900 times 2R over R minus 900 times 2R divided by 2R equals 2.5 times 2R. R's would cancel, so that gives me 1800 minus 900 equals 5R. 1800 minus 900 is 900. 5R. Divide that by 5. See, 5 goes into 9 one time with the remainder of 4. 5 goes into 48 times, so 180. What was the original question? What is the speed of each airplane? So the commercial travels twice that, so 360 miles per hour, and the private aircraft can only travel 180 miles per hour. It's always good to do these problems and then kind of approach it and then realize that there probably is a better approach. So I've done that twice now, so you can kind of see where you can go wrong, but then kind of backtrack and think about it a little bit differently. But other than that, that is all that I have for 14.7, and that's all of chapter 14. Again, as you're progressing through the homework, if you have questions, feel free to email me and let me know. Other than that, I'll see you in the next video. Bye for now.